Hello guys, welcome back to this video. In this video, let's see how Dijkstra algorithm works with an example. In this Dijkstra algorithm, we should find out the shortest path from source to all the other vertices. So we will consider A as the initial vertex A, and we should find out the shortest path from source vertex to all the other vertex. I will write the other vertices as B, C, D, E here. And initially we will check which is connected to A. B and D are connected to A. So among I will write A to B as A to B, which is of distance 3, and the predecessor of B is A, means here B A is connected to B, no, so I will write it as A here. A to B, the distance is of 3. Okay, now A to C we can't connect it directly, there is an intermediate B and D, so we will write it as infinity. And here D, which is of distance 7, and the predecessor of D is A. A is connected to D, so I will write it as A here, which is of distance 7. And here A to E we can't connect directly because there is an intermediate B, C and D here, so I will write it as infinity. And among these four, this is the shortest path, no, so I will write here A and the vertex B, which is 3. This is the shortest path between A and B, and we will not consider this here again. We only consider C, D, E. Here from B, D and C are connected. A we also already find out now this is the shortest path, so we will leave this and we will consider only these two, D and C. Here we should check which is the shortest path between B and C here. B and C, the distance is of 4, but we will not write 4 here directly. We will consider from source to all the other vertex, no, so we should add 4 plus 3, which is 7. And the predecessor of C means B is connected to C, no, this is the shortest path and B is connected to C, so we will write the predecessor of C, which is B here. Okay, and then again here D is connected to B, which is direct path, and the distance is of 2, but we should consider the distance from the source, no, so we should add 3 plus 2, which is 5, which is the predecessor B. See, here the distance was 7 from A to D, but here the distance is 3 plus 2, 5. This is the shortest path. Okay, and here E is not connected to B directly, which has an intermediate D and C, so we will write it as infinity. Among these two, this is the shortest path, so we will write this vertex, which is A, B, D, and update this as the shortest path. See, you can verify this because A to D, here the distance is 7, but here when I consider the shortest path, it is updated to 5, so this is the shortest path between A to D, which is of 5. Now we want to find out between C and E. These two are done, B and D are done. See, from D to C there is a direct path which is of distance 5, but we should consider from the source, no, so we will add 3. This is the shortest path plus 2, this is the shortest path plus 5, which is 10, and we will update this to 10. And here the distance is distance 5, 6, 7, 8, 9, 10, and here the predecessor is D only, no, so we will update this to D. But see here, if we go like this 3, 4, 5, 6, 7, 8, 9, 10, if we go like this, the distance will be 10, but see, there is another path. This is the shortest path and this is also shortest path, no, 4, 5, 6, 7. Here if we go from A to B, B to C, 4, this one is 3, this one is 4, this one results in 4, 5, 6, 7. But see this path 3, 4, 5, 6, 7, 8, 9, 10 means A to B, B to D, D to C. This one is 3 plus 2 plus 5. This one results in 10. Among these, 7 is shortest. So don't want to write this. We will continue with this only, 7 comma b. Okay. And here again, for d we will check again. For d we find out now, so we will leave this one, and we will check for e. From d to e, see, this is the shortest path, 4, from d to e, and it is connected directly. So we'll consider the distance from the source, 3 4 5 6 7 8 9 9 comma, what is the predecessor of e, which is d. So we'll write here 4 5 6 7 8 9. Okay. Then again, among these two, this one is the shortest path, 7 comma b, and we will update here this vertex, c, a, b, d, c. This vertex is also done. Now only e is left, and the shortest path is not this one, this one, this one, because see, here if you consider this path 5 6 7 8 9 10, it will become 10. But if you consider this path 4 5 6 7, this becomes the shortest path, no. So we will consider this one. Okay. Then only e is left. From c, this one is c actually, from c e is connected directly, and here it will result in 4 5 6 7, 7 plus 6, it will result in 13. If you consider 8, if you consider a to b, b to c, c to e, this one is 3, this one is 4, this one is 6, 6 plus 4 10, 10 plus 3 13, it will result in 13. But we consider, if we consider a to b, b to d, d to e, it will result in 3 plus 2 plus 4, 4 5 6 7 8 9. So among these two paths, this one, this one, this one, and this one, this one, this one, this is the shortest path. 7 9, which results in 9, no, this is the shortest path. We actually written this one 9 comma d, and we will rewrite this again. This is one is the shortest path, so we'll update from d to e. Okay, this is the shortest path. So from the source to all the other vertexes, this is the shortest path. I will write this here, a to b, which results in a distance of 3, and here from b to d, which results in distance of 2, and b to c, which results in distance of 4, and d to e, which results in distance of 4. This is the complete solution. This is the shortest path from source to all the other vertexes. I will do many examples in the upcoming videos. Thank you.